Right, welcome back to Online Study for You. My name is Ankan, and in this video we are mainly discussing the different problems of TCS NQT, the coding questions of 15 March 2025, which is yesterday. Now, so I've picked up 3 problems here which came. So the first problem, I think you can already see on the screen. It says, problem statement, making triplets equal. So you're given a triplet of integers, means you're just given 3 integers. Okay, you can perform the following operation any number of times. So 3 integers. Out of that, you pick up 2 numbers and you add 1 to both the selected numbers, and you subtract 1 from the remaining number. Your task is to determine the number of steps needed to make all the 3 numbers equal. If at all it is possible to make them equal, otherwise you have to return minus 1. So yeah. So 1, 2, 3, 4, 4, 4, 2, 2, 8. 4, 4, 4 is already equal, so the number of steps is 0. 1, 2, 3 is not possible to be made equal. 2 to 8 needs 3 steps. How is this working? Okay. If you have 2 to 8, so what it is asked is you add 1 to 2 of the numbers, subtract 1 from the remaining number. So if it is 2 to 8, first what are you going to do? Of course, we are going to add 1 to the lower numbers and we are going to subtract 1 from the greater number. If I have to make 2 numbers equal, then of course I have to add to the lower number and decrease from the greater number. That is how those numbers come closer and closer to each other, right? Great. So I'll add 1 into the lower number. So let's add it. So it will be 3, 3, and you decrease 1 from 8, it will be 7. Do the same thing, add 1 in these 2 things, decrease 1. Add 1, decrease 1. Yeah, finally you get 5, 5, 5, and they are equal. So how many steps did it take? First step, second step, third step. So answer is 3. This is how it is working. Okay, this is exactly how it is working. Now now what about 1, 2, 3? Is 1, 2, 3 impossible to be made equal? So if you have 1, 2, 3, of course we are going to follow the same logic. I'm going to pick up the lower numbers, add 1, and from the larger number I'm going to decrease 1. So you get 2, 3, and 2. Now 2, 3, and 2, I need to make sure that I add 1 to the lower numbers and decrease it from the larger number. So at any point of time, we have to sort it. So after every step, we have to sort it so that we can make sure that we add 1 to the lower numbers and subtract from the larger number. So at every step, essentially, we have to sort the numbers, right? Okay, great. So here 2 to 3. Again, I'm going to do the same thing. It will be 3, 3, 2. Wow. If you look at it now, it is impossible to make these numbers equal because this lower number have become 3, the larger number has become 3, and they have passed each other. So the lower has become the greater number and the greater has become the lower number. If it has already passed, then after this, if you continue to do the operations, what will happen is the larger number 2 will decrease and decrease and decrease. It will go to 0, minus 1, and so on. So once this has crossed each other, once the lower number has become the higher number and the higher number has become the lower number, but they haven't touched each other, then it's no longer possible for all of the 3 numbers to be equal. Right. So this is the observation. So at any point of time, so how do you, okay, so how do you check that, this kind of a condition will arise, and immediately what you will do, you will print -1, that it's no longer possible, right? So the idea is, if yeah, you can actually take one more actually. So for example, you try with something like let's say 2, 3, 4. This is also a bit different. So I think here also it will have the same thing only. So you'll get 3, 4, and 3, and then you sort it again. It will be 3, 3, 4, and then this again becomes the same thing, which I discussed, that the lower number is becoming larger than the larger number essentially. So without touching, as I discussed. So in these cases, you can find a common pattern that if you have it in this form where the first 2 numbers, the lower numbers are equal, and the larger number is just 1 more than the lower number. If you are getting these kind of a theme, where the larger number is one more than the lower number, and of course the two lower numbers are equal, then it's no longer possible to make them equal. Why? Because when you add 1 to the lower number, it becomes 3. But the problem is the number 3, which was one more, also has to be decreased. So the lower number increases by 1, the larger number has to decrease by 1. So again, they are crossing the threshold. So whenever they are at a difference of 1, these kind of a theme, then you immediately return -1 because that's no longer possible. Okay, so the advantage of this question is you can simply do a brute force each other. So I had a talk with some of the students. Brute force approach is really more than enough for passing all the test cases in this problem. So you simply can do brute force. Okay, brute force means whatever it is asked in the question, right? You add 1 to two numbers, subtract 1 from the other number. You simply do that in your code, brute force directly, and you continuously do it and do it and do it until you get a form like this, where it's no longer possible, or until you get somewhere where all the three has become equal, like in this case. In either of these two cases, you simply exit from the loop, otherwise the loop will go. So essentially you can take an infinite loop where it will continue to do and do and do, and only when this case is same, I mean all the three numbers are same, this case, then you found out an answer, and or else you have this kind of things where it's no longer possible to find out an answer. In either of the cases, you simply have to return either the number of steps in this case or -1 if it's not possible. Okay. So I've written the code here. You can have a look. This is the code in C++, of course. So it's very simple. So you take the three numbers as input, P, Q, and R, and this is the min steps to make them equal. And what you're going to do is you're going to take a vector, and in the vector you're simply going to put up all the three numbers, simply sort the vector. And if this is already equal, then you return 0. So like in this case, 4, 4, and 4, if all of these three numbers are already equal, then you return 0. Okay, otherwise you simply take an infinite loop. You add the first two numbers, decrease the third number, and of course add the number of steps. And after every step you have to sort. So sort the vector. Okay, if all three are equal, then you return number of steps. Else you see that the lower numbers are equal and the larger number is one more than the lower number. So if it is like v0 equal to v1 and v1 plus 1 equal to v2, because you have to make sure, I mean you already know that v0, v1 and v2 are sorted. So 0 and 1 are the lower numbers, and if v1 plus 1 equal to v2 in this case, or the other case, v1 is equal to v2 and v0 plus 1 is equal to v1. Okay, in either of the cases, you know that this is no longer possible. Okay, and you have to return -1. Okay, so this is the approach which we will follow. Okay, I guess you can also run the code. So I'll just run this. I have to input three numbers. So if it is 1, 2, and 3, it's never possible. So you return -1. Else, if we had the other case, right, 2 to 8. Yeah. So if we have 2 to 8 here, it will be 3 steps as we had discussed here. Okay. Right. So we also have the Java code is exactly the same. So you can just have a look. Yeah. So same thing. You just take the three integers. I've taken scanner input. So essentially, okay, you do not need to print enter three numbers, I guess, so that you can adjust. So if you want me, you can even rub this part. Okay, but for now I have kept it. So you just take three you just input, you call the min steps function, and you know what to do. Just take an array list, you add all of them and you sort it. Okay, exactly the same what I have done here. Okay, here also we are sorting it. Then you know what to do. If all three are already equal, then you have to return 0, no steps. Else you set all of them, so you add them by 1, add the lower numbers by 1, add the third number will be decreasing by 1, and then you number of steps will increase, and then you sort it again. Okay, any point of time, if all three are equal, then the number of steps, you know, because I just read the number of steps, they are already equal. Else the same condition which I had here. Okay, if couple of numbers are equal and you find out that the third number, the larger number, is just one more, they can never be equal, because when you increase the lower number by 1, the larger number also has to decrease by 1, and the numbers cross each other. So after that, they can no longer ever meet each other. Okay, you can also run this, but yeah, the concept remains the same. So 2, 2, and 8, and you get 3 here. Okay, so this was the problem. It was pretty simple. By the way, in this question, you can also take a simple array. You know, I am hooked on taking Java elections. So here also you can use with array, although I'm more comfortable with vector. But yeah, the solution remains the same. Okay. All right. Right. So this is another question, which is range sum query. I guess this question also came yesterday. So it's 15th of March. Morning shift. So I think if you can read this question, this was a really simple question. I saw that a lot of people had doubts in this. You're given two integers I and j, okay, and the integers are from 0 to 9999 included, both I and j included. So it's 0 to 10,000, I guess. Constants are 0 to 10,000, but okay, 10,000 is not included. Yeah, 10,000 is not included. Okay, so so suppose somebody gives you like 10,001, right? So this would be included. In fact, if it is 10,000 here, then also it should be not included. Okay, I'm not exactly sure of the constraints, right? But I guess I see it's from 0 to 9999, both are included, right? So if it is, so if I and j will be given to you, if j is here, if you look at it, it's 10,000. So that is outside 9999, right? Okay. So it's extremely simple. What you have to do is simply add all of them, right? Simply add all of them. So now suppose, okay, one easy way of doing this is a simple math trick, if you know. So suppose you have these numbers. Yeah, so starting from 0. So 0, 1, 2, 3, 4, 5. Okay, somebody asks you to find out the summation of 3 to 6. Can you write a formula for that? One thing you know, that the summation of 6 is nothing but n into n plus 1 by 2. So 6 into 7 by 2. Okay, so the formula is, I hope you know, it's n into n plus 1 by 2. Right? And you also know the summation of 3 by the same formula, which is 3 into 4 by 2. Right? So this is 21. This is 6. But the thing here is, can you write a formula here for doing the sum from 3 to 6? Right. So from 3 to 6, okay, this is something we also do it in prefix sum. It's also really similar. So the summation of 3 to 6 will be nothing. So summation of 3 to 6, it will be nothing, but it will be simply be summation of 6 minus of summation of 3 minus 1, which is summation of 6 minus summation of 2. Why? Because I have to exclude this part. I do not have to exclude 3. If you do summation of 6 minus summation of 3, it will be wrong. It will be summation of 6 minus summation of 3 minus 1, because 3 to 6, 3 is included in your sum. When you are doing from 3 to 6, 3 plus 4 plus 5 plus 6, then essentially this 3 is included. So your answer will be 7 plus 5 plus 12 plus 6 is 18. So your answer will be 18. From 3 to 6, the summation is 18. How are you getting it? You are getting it by this formula. So summation of 6 is 21 and summation of 2 is 1 plus 2, which is 3. So this is 18. Answer will be 18. So you can always remember the summation of any two numbers here, I mean a range, will be summation of the larger minus summation of smaller minus 1, because this number 3 is included in your sum. 3 plus 4 plus 5 plus 6. So this is the formula which you can use. Okay. But I guess the main problem, what I think a lot of people had is I think 6 out of 7 test cases got passed. And I think the answer to that is really silly, is that the TCS, the way the compiler is, the way this print statement is given, first of all, you shouldn't do this, but okay, TCS does this. So you have to print it in this format. Okay, exactly in this format if it is invalid. But I think a lot of people, what they were doing, they were having some problem in the spaces. Somewhere it had 2 spaces in between, somewhere it had 1 space in between, you know, somewhere it didn't have any space in between in this particular line. Right. So that is what you, because of which that I think that was the 7th test case, and because of that you guys, you know, test case is failing. But yeah, this is a very you know, I'm a bit amazed, because, you know, in case of invalid, you should just print -1, but TCS doesn't want that. They want us to print this string. Okay. And because of this wrong printing of string, some spaces in between, people are getting like one test case wrong, 6 out of 7. But okay, so yeah, so the question is really simple. We're just going to follow that. But the problem there is a major issue here, which is you need to take input of 0 to 10,000. So how are you going to take the input? If you have watched my how to take user input video here in this channel, how to take user input in C++, I have discussed something called a string stream. That is the perfect way in which you should take input here. So I hope you know what you mean by string stream. Here in C++, you use cin, right? You do something like this, cin AB. Cin is also a stream. So what you're doing is you have all the numbers coming in a stream and you're reading from that stream. So A and B, you're reading from the cin stream. Similarly, you can create a stream here from where you can start reading these values 0, 3, 2, 6, whatever it is. Okay, so that can be used in C++. Or in Java, what you can do is in Java you can simply separate it out. So for example, here it is 2, 6. You can simply split by a space. You can simply split by a space and you can get access to both of these numbers. Once you get access to both of these numbers, then you can simply store it and perform this operation. Okay, s of n minus s of the smaller number minus 1. Okay, so yeah, the code is this, is extremely simple. You have to take a string stream and I and j has to be taken input. If any of I or j is not there, you know, in your input, which means somebody doesn't want to even input I and j in your input, then you simply print invalid input. This is the problematic line, I guess. Here I and j, probably there is no space mark in between. I mean, you guys can understand when you sat for the exam, and here somewhere it is 2 spaces or 1 space. My point is this spacing should be completely same, because otherwise compiler would assume that this is wrong. Okay, spacings should be same. That is the 7th test case where a lot of the test cases were failing. But I am really surprised that you shouldn't be doing this to candidates. You should simply be asking to print -1, right? But anyways, okay. Or you see this is less than 0. This is greater than equal to 10,000. Greater than equal to 10,000. So even if it's 10,000, as I discussed, it is wrong. Okay, so this is wrong because this is out of range essentially. Or I is more than j, then of course it is there, because I is the lower or j is the greater. Otherwise you simply do this. S of j is n into n plus 1 by 2, and this is I into I minus 1 by 2. How? Because you're doing s of n minus 1. So n minus 1, you're doing s of n minus 1. So if you put it in this formula, n into n plus 1 by 2. So n would be n minus 1. Okay, so n is n minus 1, n into n plus 1. So it will be n minus 1 multiplied by n minus 2, n into just a second, n into n plus 1 by 2. So n into n is n minus 1, n plus 1 becomes n minus 1 plus 1. Okay, by 2. What I am doing here is the formula n into n plus 1 by 2, right? Instead of n, you put n minus 1, then you'll get this. N means n minus 1, n minus 1, n into n minus 1 plus 1. Okay, so n minus 1 into n by 2, right? Okay, just a second. Let me just rub this. Yeah, so this is the formula. Simply put instead of n minus 1. So n minus 1 multiplied by n minus 1 plus 1 by 2. So here from here you will get n into n minus 1 by 2. So this is the formula. N into n minus 1 by 2. Okay, so I is the lower limit, I into I minus 1 by 2. This is the exact same thing what we do in Java as well. Exactly the same thing. You just read it. Okay, in Java you split it by space. Okay, and once split it, you can simply get it in your array, all the digits. And once you get that, I mean all the digits are numbers, and once you get that, you simply do the same thing. You just call the function here. Okay, you can run this. Suppose you want from 3 to 6, that would be 18 as we had seen just now. Okay, or if you want like 1 to 10,000, this would be invalid input. Okay, again this line has to be printed exactly as it is. Okay, this question was also exactly similar. I mean, this maths had to be like, this math should be really, I mean, if you guys are giving aptitude exam, this should come right out of your mouth. This is as simple as it gets, right? Okay, so I'll go over to one more question now. Right, so if you have solved lead code, then this is a very famous problem. It's known as single number, or finding the unique element in your array or vector. Right. So I can straight away show you guys that. So this is the solution as well, which will come down in a second. But the question is exactly simple, very, very simple, that you're given an array and every number here is repeated twice, except one number which is repeated once. You have to find out that number which is present only once in the array. Okay, you have to find out that number which is present only once in the array. All other numbers are present twice. Okay. So if we look at this, I mean all other numbers, if they are present in the array at all, they are present twice. Okay. Else a single number is present only once. Okay. So if we look at this here, 4, 1, 2, 1, 2. So 1 is present twice, 2 is present twice, but 4 is present once. So answer is 4. Okay. Here it is only 1. Here it is 2 is present twice, 1 is present once. Answer is 1. Okay. The easier option, the easiest solution to this problem is using the XOR operator. Okay. So the idea here is 4, 1, 2, 1, 2. What I'm going to do is I'm simply going to loop over and I'm simply going to XOR it. So if this is the array here, so what it will essentially be is I'll take a variable like XOR x equal to 0. I'm simply going to do x XOR whatever is the array of I. This is exactly what I'm going to do. So what will happen is it will be it will be 0 XOR 4 XOR 1 XOR 2 XOR 1 XOR 2. Okay. Now, what are the properties of XOR? 0 XOR with any number should give you 0. I mean, 0 XOR with any number should give you the number itself. Right? And x XOR x, two numbers having XOR should give you 0. Essentially, they should just cancel each other off. So what do I mean is, 0 XOR 4 will be 4 only. So 0 will be cancelled off. But if you look at this, 2 and 2 will cancel each other. 1 and 1 will cancel each other. So the answer will be 4. Right? Because two similar XORs, they essentially cancel each other or 0. And 0 XOR a number is the number itself. So all the equal numbers, I mean, the numbers which are present twice, one number will cancel the other number. So this one will cancel the other one, 1, 2 will cancel the other 2. And 0, okay, z0 XOR is z0 XOR any number is the number itself. So 0 is also cancelled. The number remaining is your answer, which is 4. This is the easiest solution. This is the solution which I have here. Take a XOR, just loop over, simply do the XOR operator. Whatever is your answer of the XOR operator at the end of the day, whatever remains after you perform this XOR operator, the answer of this is 4, because that is the answer. So whatever is your answer of this, that is your answer, which is 4. Okay, and this will obviously pass. This is the most simple solution if you know about it, because this is a very common problem. However, even if you don't know about it, you can simply use maps, right? You can simply use map to calculate the frequency, right? So the other approach here is use map to calculate the frequency. Okay, if frequency of any number is 1, which I'm sure there is a number in the array whose frequency is 1. If the frequency of any number is 1, simply return that. Okay, so take a loop first, calculate the map, take another loop, and in that loop you just loop over the map and find out which frequency is 1 essentially. So this is also very simple. Take a loop, find out the frequency. We know very well how to calculate the frequency of num++, and then you loop over the map again. And if any frequency p dot second is 1, then you return the p dot first. I hope you know what is p dot first and p dot second. How does map store your answers? So map will store something like this. So in this case, it is like 4, 1, 2, 1, 2. So it will store the frequency of 4 to be 1. Then 1 is present twice, right? And then 2 is also present twice. So this is how it will store in the map. Key value pairs. So the idea is this is the number itself and this is the frequency of the number. So the idea is the first is the number, the next is the frequency. Okay, 4 is present once, 1 is present twice, 2 is present once. This can be accessed by dot first, this can be accessed by dot second, which you see here, dot second, dot first. So if any of the frequency, which is dot second, is 1, then you return me the dot first, which is the number, right? If any of this, this is dot second is 1, you return me the number. Okay, if it is not present, by the way, if it is not present, you return -1. Same thing here is the same thing with Java. Just take a map, do the exact same thing to calculate the frequency. If any of it is 1, then you get the key. If it is not, then you return minus 1. Okay, then you return minus 1, that if no single element is found which is only once. Okay, so in this question, if you have to handle that case where it may not be where it may not be an element is not present once, then you simply check if the XOR operator is 0. So suppose you had something like this, 2 2 1 1. In this case the answer will be minus 1 because no single number exists. So in this case the XOR would be 0. Okay, so if the XOR is 0, then you simply check if the XOR operator, when whatever is your answer, if XOR operator is 0, then you don't have any single number, then you return minus 1, else you return whatever the XOR operator is. Right, so that is it if you want to go by the XOR option. Right, anyways, but this question was also really simple. You don't know the XOR, just do the simple process of using maps, right? All right, so that was it. The questions were pretty simple in my opinion. I will meet you in the next video. Thank you for watching.